So this video is on tangents and chords. So let's start with a tangent. So a tangent is a line that touches a circle once. So let's see a couple examples of this. They can be obviously in all types of positions. So a tangent could be like this here. A tangent could be in this position here. And a tangent could be in a position like this. It could be anywhere on the circle, it just has to only touch it once, like this. So there it only touches it once, there it only touches it once, and there it only touches it once as well. Now the important thing with tangents is that the radius, or the diameter, as they're basically the same thing, will be perpendicular to the tangent. So if we show this, so let's say the centre is here, and here, and here, remember the radius comes from the centre. The radius will look like this, and it will be perpendicular to the tangent. The radius will look like this, and it will be perpendicular to the tangent. And the radius will look like this, and it will be perpendicular to the tangent. It will be a 90-degree angle. So if you see a line that's perpendicular to a tangent, it's the radius, or it's going to be part of the radius anyway. Obviously it could be the diameter as well, but part of it is going to be the radius, or the whole thing is going to be the radius. And note that as the radius passes through the centre of the circle, this is quite useful for finding the equation of a tangent, which we'll talk about in a sec. And as the radius and tangent are perpendicular, if we know the gradient of the radius, we can easily find the gradient of the tangent. It's just going to be the negative reciprocal. We went over this in the parallel and perpendicular line video in straight line graphs. So if the gradient of the radius is m, let's say, in fact, let's do this in a different colour. Let's say the gradient of the radius is m. The gradient of the tangent is going to be -1 over m. Again, look at the parallel and perpendicular lines in the straight line graphs if you don't understand this. So, for example, if the gradient of the radius is 2, the gradient of the tangent is going to be -1/2. And this is really, really useful for finding the equation of a tangent. It's a very common thing for them to quiz you on in questions. So the spec specifically says that you should be able to find the equation of a tangent at a specified point using the perpendicular properties of tangents and radii. So you definitely need to know how to do this, and I would note down this question or a question similar to it, because the spec specifically says that they could ask you a question in this style. So the question will be worded like this, where they give you the equation of a circle and they give you the point in which a tangent is connected to the circle on the circumference, and they want you to find the equation of this tangent. So what I would always do for these questions, if it is not given to you in the actual question, is I would always sketch a diagram, as I think this really puts the question into perspective, and I think it makes it a lot easier to understand. I'm not going to do an axis because they're not going to mark you for the diagram at all if you draw it. I'm just going to draw a circle. I'm not going to do the axis because that will just take up unnecessary time. And we know the centre is -3, -4, and the point -60 I'm just going to do up here. Again, the scale doesn't matter at all. It doesn't matter where you put this point. I'm not bothered about an axis or a scale. And there is a tangent at this point, and this is the point -6. 0. And I'm going to draw the radii in because we're going to need this for the question, as we'll see in a sec. And the radius is perpendicular to the tangent. So how do we approach this question? Well, the first thing we can do is we have 2 points on the radius. We have the centre and we have the point the radius is connected to on the circumference. So therefore we can find the gradient of the radius. This is all R here. I know I really used to hate subscripts at the start of A level, these little like letters here. All this is just a labelling. This means that I'm talking about the gradient of the radius. This is all this little r means, because we're going to be talking about multiple gradients in this question. You don't have to do this if you don't want to, but I find it quite useful in order to make sure I don't get confused with the different types of gradients we're going to be doing. So this little r here, all it represents is I'm talking about the radius. So the gradient of the radius with this labelling here is equal to -4 minus 0 over -3 minus -6. And if you put this into a calculator, this is equal to -4 over 3. So as the gradient of the radius is equal to -4 over 3, the gradient of the tangent, again this t just represents that I'm talking about the tangent this time as opposed to the radius, so we can distinguish these two different terms. But again, you don't need to include these if you don't want to. All these mean is just that you're labelling the different gradients. So the gradient of the tangent, as the gradient of the as the radius and the tangent are perpendicular to each other, the gradient of the tangent is going to be the negative reciprocal of the gradient of the radius. So the gradient of the tangent is going to be 3 over 4. And we know a point on the tangent, -6, 0. So therefore we can use the equation y minus y1 is equal to m x minus x1, the straight line equation, and we can sub in the values. We can do y, and we're going to use this point here on the tangent, so it's going to be y minus 0, which is just equal to y, is equal to m, which is 3 over 4, that's the gradient of the tangent, x minus x1, which is -6, so it's going to be plus 6. We can simplify this by expanding the brackets to y is equal to 3 over 4x plus 9 over 2, and then we can bring everything onto we can bring the y onto the other side to do 3 over 4x minus y plus 9 over 2 is equal to 0. But remember, we need to make everything integers, so we're going to times everything by 4 to remove this denominator, and we'll remove the 2 as well. Hence, so if we times everything by 4, it will become 3x minus 4y, and it will become plus 18, because times 2 will remove the denominator, but we'll times them by 4, so it's also going to times the numerator by 2 as well, so it's plus 18, and this is equal to 0. And this is the final answer to the question. This is the equation of the tangent. And as I said, because the spec specifically talks about this style of question, I would note down specifically this method and how to do it, as it is it's quite likely that it could come up and they could ask you it as the spec specifically mentions it. So before I talk about chords, I just want to quickly talk about something called a perpendicular bisector. So what's a perpendicular bisector? Well, a perpendicular bisector, as you might guess from the first part, is a perpendicular line. You can obviously infer this from the first part. And it's a bisector. So what does the term bisect mean? Well, the term bisect means that you split a line into 2 equal parts. So a perpendicular bisector is a perpendicular line that splits another line into 2 equal parts, and that's what the bisector part is. That's why that's there. That's what that means. It splits another line into 2 equal parts. So let's draw this on a diagram and show what this actually means. Let's pretend we have 2 points. Point A, we'll say, is here, and point B, and let's have line AB that connects points A and B. So we have now line AB. The perpendicular bisector of line AB is going to be perpendicular to the line, and it is going to split it into two equal parts. This is what these two dashes mean here. But they're both one dash, so therefore they are both the same length. And that is what the perpendicular bisector of line AB is. And you're able to find the equation of the perpendicular bisector, because if you know points A and B, you can find the gradient of line AB, which let's say is m, and therefore you can find the equation, the gradient of the perpendicular bisector as just being minus 1 over m. And you can find a point on the perpendicular bisector as the midpoint of AB will lie on the perpendicular bisector. So remember, it splits the line equally into two, so therefore it has to go through the exact midpoint of the line. We talked about how to find the midpoint of a line in the equation of a circle video in the circles chapter, so in the circles set of videos. So go over that if you're not sure. So for example, let's say that point A is 2, 4, and let's say that point B is 6, 8. Well, we can find the gradient of line AB as being 8 minus 4 over 6 minus 2, which is just going to be equal actually to 1. And therefore we can find the gradient of the perpendicular bisector. I haven't done any kind of symbols here, but it doesn't matter too much. We can find the gradient of the perpendicular bisector being the negative reciprocal of 1, which is therefore just going to be minus 1. So that's the gradient of the perpendicular bisector. So now we need to know the midpoint. Well, we can find the midpoint of AB. I'm just going to do it in my head. So we need to find the midpoint of the x coordinate and the midpoint of the y coordinate. The midpoint of 2 and 6 is 4, and the midpoint of 4 and 8 is 6. Go to the equation of a circle video in the circles video if you want a more in-depth explanation of how to find the midpoint. So that is the midpoint. So therefore we can write the equation of the perpendicular bisector as y minus 6 is equal to minus 1 x minus 4, and then you can further this and put it into the form a x plus by plus c is equal to 0. But this is a equation of the perpendicular bisector.